Keil Microvision Integrated Development Environment is an ARM software product that can be used to develop applications for virtually any ARM Cortex-M series processor. For most hobby and beginner projects, the free evaluation version works great and mainly only limits the executable image size. Pause the video here if you'd like to see all the limitations. Some of its many features include built-in debugging with breakpoints and the ability to monitor peripheral and core registers, project dependency management, and a graphical configuration menu. If your project needs to run on multiple ARM processors, setting up a multi-target project is possible as well. In this video series, I hope to cover these features, but for now, let's just get ourselves up and running. We'll be going over installation, project setup, and what resources to gather before committing to a productive development session. I'll mention at the end where to go from here. Let's get started. Alright, let's open up our browser and search ARM Keil uvision. Find it at keil.com/uvision. Go to download, product downloads, MDK ARM, and then you're going to have to fill out this form. So go ahead and do that. Once you have it filled out, if you already know what processor made by which silicon manufacturer you'll be using, you can check the box. It really isn't going to matter. You're going to be able to download it either way. So I'll just check a few of those, click submit, and download the installer executable. This software is Windows only, unfortunately. There are other ways to do development with ARM microcontrollers and microprocessors that I'll cover in other videos, but this is definitely the easiest way, in my opinion, to get started. While we wait for it to download, let's look for some of the reference manuals and datasheets we'll need to work on our project. In my case, I'm using an STM32F767ZI, and this is the development board I'll be using. It's STM32 Nucleo 144. So here's the board. You're going to want to find the datasheet and download it. I recommend going into your documents folder and setting up a development folder. ARM dev. I'll make ST32. I'll go into here, so I'll save that there for now. I'll name it give it a name, and then we're also going to want the reference manual. So we'll scroll down. We want the reference manual and the programming manual. This is going to be a huge document, 21 megabytes, about 2,000 pages, but as you'll see, it's going to be a lot harder to work without this. Reference manual. Grab that. We want to grab the programming manual because that tells us a lot about the ARM core. In this case, it's an ARM Cortex-M7. We'll save that. So it looks like our installer is done downloading. We'll go ahead and install it. You can just click through it. You don't need to change any of these. If you can, if you want to. I usually don't. Yep. So, and then we'll wait for this to install. Yeah, you want to take this time to find any sort of documents and reference manuals that might come in handy. In my case, I know that this development board has an onboard debugger. It's an emulated ST-Link V2, which is a debugger that ST Microelectronics makes. Instead of having to buy it, they provide it right on the board itself. And actually, let's say you've actually programmed your application, you can cut it off and you can use the board without that. Anyways, you need a driver for that, and that's something it looks like you can find clicking through their menus. Every manufacturer's website is going to be set up a bit different. I already have the driver installed, but if I needed to install it, this is where I would go for that. There might come a point with some of these manufacturers where they want you to create an account with them and register to get to the next step of downloading a certain manual or downloading a certain driver. There's really no way around that. You're going to have to make an account in a lot of cases. Yeah, once it's done, it's actually going to open up the pack installer. So what this does is, as I mentioned in the intro, Keil can keep track of your project's dependencies, and I'll get to what that really means, but essentially what it's doing right now is it's downloading all of the information for what boards and software packs it comes with. Let's say you buy a development board. A lot of the development boards have existing projects for you to use as samples, I mean, it's a development board that a lot of engineering went into, and the code for you to be able to use it already exists. This is a way to easily access that through the IDE. So I logged in, and when I was logged in, I didn't notice it, but it just downloaded the driver for me. Here it is. I'll just show you what those often look like. But now that it went through and updated everything, the first thing I like to do is look over here and just update this random middleware. Definitely update the compiler. There's really no reason probably to update this MDK middleware unless you're going to use any of these things. But what you definitely want, and in my case I have the ST microelectronics STM32F7, so we'll open up that menu, and I have the 767ZI. So I'll go there, I'll click on it, and then on the right it's going to give you the option to install, and that is what I want to do. Now this is going to take a while because this is like almost a gigabyte of stuff. I don't know why it's that much. You'll come to see how useful it is later on when we actually start writing some code. For any project, before you get started, you're going to want to go into the pack manager and find the software pack for your particular processor, because that's going to give you access to all the header files you'll need, and depending on if you want to do it all from scratch or you want to use all of the written drivers, you'll be able to just jump right in. This is one of the main reasons that this development environment is great for getting started type of projects, because it's much more difficult to just go and install the ARM compiler, get a make file going and do everything with a third-party debugger and debugging from the terminal and things like that. You get around having to, like if you want to actually develop a professional product, you might have a tough time using the free version of Keil. The ways around that force you to have to do a lot more work and know more about what you're doing. While we're waiting for that to install, if you have a development board, it's not going to be enough just to have all your data sheets and reference manuals for the processor. You want to have some kind of manual for the board itself. I have the board right here. So I don't know if that will focus, but for instance, this has a blue button right here, and it has 3 LEDs right here. So in order for me to interact with those components, I need to know which pins they're connected to on the actual processor, and there's no reason for me to take a multimeter and try to figure out which one. Obviously that information is provided, so you're going to want to have that bit of information with you. I'll just search the Nuclear 144. Here it is from ST. It looks like that's probably the PDF for it right there. I don't want the data brief. User manual, here we go. This might be it. So if we look through it really quickly, let's look for hardware layout, LEDs. Yeah, so user LED 1, PB 0, and then actually what's interesting about this board is that there's a bunch of things that are also unpopulated, like right here. They give you the option to add your own oscillator if you want. Otherwise, we'll get to this, but the oscillator signal is coming from the debugger, and a lot of these solder bridges on the back, you can either just bridge them with solder, or you can add a 0 ohm resistor, and you can change the configuration of the board. So it's really well engineered, and unfortunately, before you just get this thing in the mail and start programming it, it's going to take reading a lot of this literature before you fully understand how it's all set up. So now that our pack installer is done, if I plug in the board, we'll be able to find out if the USB driver is installed or not. So it looks like this particular board exposes itself as a USB drive, and the reason for that is it's part of a class of development boards that are known as being mbed enabled. I'm not going to talk about what mbed is. If you Google it, you can compile programs online using a much more abstracted Arduino level of abstraction software ecosystem. And essentially what you do is you compile it online and you download the image that will go on the board and you drag it into this folder, and the debugger will know to program the device, which is pretty cool. We're obviously here because we're hoping to get a little bit closer to the hardware and figure out how these things actually work and how to program them. Because if you're using Keil, what's been implemented with mbed is what you're hoping to implement yourself in most cases. if you just need to get an application, let's say some kind of IoT application up really quickly, you're definitely going to want to utilize Embed if it's available to you. If we open Device Manager, we can see that this exposes itself as a COM port, so we can get serial output out of it. But it should also be, yeah, ST-Link debug. So we'll see later on how to actually use this debug driver in order to write our application. All right, it looks like the pack installer is done. So let's go ahead and close everything. Let's just for now put all of our documents in a new folder, and then let's open up Keil. All right. So this is what it looks like. It's very Eclipse looking. You're going to want to go to Project, New Project. I'm just going to put it in this root folder here. We'll call it Up and Running. Save it. Now, this is at which point you need to choose which processor you're doing this project for. And so I'm going to choose my processor, hit OK. Here is where you can decide if there are any dependencies you know of that you're going to be utilizing right away. A very common one is the CMSys, which is a middleware tool made by ARM that essentially standardizes an interface for you to interact with a microcontroller, so that if you're going to do an ARM processor project, you can use the CMSys functions and either implement the HAL layer, hardware abstraction layer, yourself, or utilize the vendor's hardware abstraction layer drivers. In the case of this processor, ST actually does have a full-featured hardware abstraction layer set of drivers that's made specifically for CMSys. So all the functions you could call could be CMSys, as long as you have also in your project the hardware abstraction layer. And I'll show you how that looks. Let's say we don't even know what this is. We go to Device, we go to HAL, and we want, let's say we want UART. You see that it's in yellow. So we need the common driver, the DMA driver. Okay. Common DMA. Now it's saying we need Cube framework. So we need the Cube framework. As you can see, like we need CMSys core. Okay. But you see, like, oh, well, all I wanted to do was I wanted to get this board. I wanted to get some UART going. It starts to become a huge, just endless codependency. Like, you start to introduce a lot of dependencies into your project before you've ever even used it before. You don't necessarily know why, for instance, your UART driver needs a DMA driver. If you're experienced, you know that the DMA is probably capable of helping ease the load of loading a byte or reading a byte every time you get one. Like, let's say you want to send 50 characters. Do you need to sit there and wait until they're all sent if you're sending at a slow baud rate compared to your fast processor frequency? That's where DMA can make it much easier for your UART engine and your processor to continue working. So what I'm actually going to do is I'm not going to do any of these dependencies. I'm going to uncheck the dependencies. The only thing I'm going to grab is the startup files. And well, I'm going to grab for now. So you need to grab CMSys core and your startup files pretty much no matter what. But I'll show you what you can do to get them into your own file system so you don't need to do that. So we'll hit OK. And let's just look at what they created. So